Hey YouTube, it's Dimitri, and today we're going to filter matrices here inside of R. So part of this R series here, if you are not following along, I am somewhat using the Art of R programming here by Matloff. Really like this book. This gives you kind of a general idea and explains some things in more detail. I explain them a little bit differently, but kind of generally follow that book and is part of this video series on R. So today we're going to talk about filtering out matrices based on conditions with a column. So often we have some sort of matrix. Every column is going to be some sort of variable, and often we want to look at different rows. So look at a column, find values within there that meet some sort of condition and keep those, and then drop the other values or the other rows within that data set that do not meet that condition here. So let's just dive on in here with a few examples. We first need to create our matrices. X is going to be assigned to the matrix, and we're going to do matrix function with C. And we're going to use the values 1, 2, 3, 2, 3, 4, 7, 1, 4, 6, 5, 3. And we're going to set this up to in row. So the number of rows is going to be equal to 3. And the number of columns is going to be equal to 4. And then I'm also just going to write X below so we can print this out and look at it. If you're curious, on the right-hand side up here in R Studio, you can double-click that, and it will print this much prettier version of the little table. But for ease of showing you guys inside the programming language itself, we're going to print it down here with just printing X. So as you can see, this is going to be our table that we're going to be referencing. And we want to keep rows based on a condition for a single column. If any value in column 2 has a value greater than or equal to 3, we're going to keep those. So we're going to create a new matrix called Y. We're going to do this just so we don't overwrite the original X matrix as we call it multiple times. I think it's easier for teaching here to see taking one table and then doing multiple things to it, but we don't want to overwrite it. And so what we're going to do is just take the matrix X itself, and we're going to select that second column here. So if you remember, we have X as the matrix. The first attribute is going to be the rows. We're not going to put anything in there because we're going to be keeping all the rows. We want this condition to look through all of them. And then we're just going to reference that second column. And then we're going to say that this is greater than or equal to 3. And we're going to leave this blank. So if you remember, anytime, just write this out here. Anytime we reference a matrix in itself, the first part is going to be the rows and the second part is going to be the columns. So that's what we're going to do here. This is just a note. And so this part is going to be the condition of those rows based on a specific column. So we're going to say, you know, given the rows, we're going to keep these specific rows that have column 2 that is going to be greater than or equal to 3. And then for the column section, we're just going to leave everything else the same here. We're just dropping rows. And then I'm going to print Y underneath so we can look at that as well. And if you look here, and any value that is going to be greater than or equal to 3, so of course, the first one is not, that is less than 3. And then 3 is equal to or greater than, and so is 4. So we would expect that this first row is dropped just because column 2 does not meet that condition. And as we printed out Y from that condition that we wrote, you will see here that we kept rows 2 and 3, but we did drop the first one. I will importantly note here, the index here re-updates to 1 and 2. So it was technically 2 and 3 in the original one, but it's going to reset them as it creates the new matrix here. All right, so the next case here is going to be multiple conditions. What if there are 2 conditions that we need on different columns, and it needs to meet both of these to be able to be kept, and then we need to drop everything else. So first off, we're going to talk about multiple conditions. So let's do an example here with multiple conditions, and we're just going to call this one A, and we're going to assign to it X of 2. So we're going to use the second column again. And we're going to do greater than or equal to 3, just as we did above. But now we're going to add the and sign, or the ampersand here. And we're going to add a second condition here. So and, let's do X. Let's say column 4 for this example is going to be less than 10. And then we're going to have a comma, and we'll leave our columns blank again. And then we're going to print this to A real quick so we can look at it. And as you'll see here, we get the exact same result in this new A matrix here as we did above in our Y matrix. So let's just look at the logic behind this. So let's print logic. And the logic here is going to be that both conditions are met in this case because it's an and. So the first condition and the second condition both need to be met to keep the rows. not to drop them. So it gets a little confusing if you think about dropping them. These both need to be met to keep rows. So I'm going to put keep here in bold. And then we're going to print these out. So a logic is going to be assigned our first condition here, and you can just copy and paste from above. And then let's do a logic 2. And again, we're going to copy and paste the second logic from above. And then let's print these out real quick just so we can look at them. And you'll see it says false, true, 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 true. So this is the keep statement. So we need both of these to be true to keep them. So you will see the second ones right here for these two conditions are true, and the third ones are true for both conditions. So we should see just these sets. The real issue is that the first row is going to be false in the first condition and true in the second one. So both of them are not true. So it's not first logic and second are true. So therefore we're going to just drop the first row. And you will see here as we print it out with A, our original X1 is here. And we drop that first row just because that first one fails. But the second one is still less than 10. But both conditions are not met. So therefore it's not kept. So let's put a note in here. Row 1, not greater than or equal to 3 in column 2 and less than 10 in column 4. Now, rows 2 and 3 are met in the sense that they are greater than or equal to 3 and are less than 10 in column 4. So since both conditions are met, we keep both of these. Now let's do one more example here with the multiple conditions here just to show you what happens when we end up with just one row that comes out. And also just another example to kind of see here a little bit more of the dynamics. So we're going to create one called B, and we're going to assign to it X greater than or equal to 3, just like before. But in this case, we're going to substitute this out for this column 4, which is going to be less than 4 instead of less than 10. Let's print this out real quick. You will see here, I am missing my matrix format. I don't have like all the columns listed in all the rows, but it does have these. Let's go through the logic real quick, and then I'll show you why that happens and how we can fix it. So the B logic, and again, we're going to copy and paste as we did above. And then the B logic 2, we'll copy and paste the second condition here. And then we'll print these out real quick. And as you'll see here, we have a false, false. So again, we don't have a pair of true and true. We're looking for that true, true. So we're going to drop that first row here of the matrix, right? Because we have a false in there. We don't have multiple trues here. And then the second one is going to be true and false. So in that table of column 2 greater than or equal to 3, we see this is greater than or equal to 3, because we're equal to 3. However, for the second condition here, for the fourth column, we want to see less than 4. And we run up to here for column 4, second row. Is that less than 4? No, that is a false as well. So we'll have to drop the second row. And then finally, the third row of this, again with column 2 greater than or equal to 3. And then column 4 less than 4. We have this case because this is greater than or equal to 3, and this is going to be less than 4. So the only row that we are going to keep in this multi-filtering example of the matrices is going to be the last one. All right, so since single row is left, it converts from a matrix back to a vector. And so the workaround for this for now, we will go into applies later, applying functions and doing all that, is just to convert it back into a matrix using the matrix formula. So let's just convert back to a matrix. And we're just going to overwrite it as well. So we're just going to say B is going to be assigned matrix. And we're going to take B as the input. We're going to convert that back to a matrix. And then we're going to have in rows is going to be equal to 1. In calls is going to be equal to 4. And you'll notice here right before we run this, our B, which is in our values section on the right-hand table here, is going to get bumped up into our data section instead of it being a value. And there we go. B got bumped up, as you can see right here, into our data, and it is now missing from our values. So that is how you filter matrices using either single or multiple logics here. You can just keep adding the and sign. You can add multiples if you need 3 or 4 or 5. I don't know why you would, but if you had some sort of complex condition with multiple columns, you can use that. You can use a condition on the same column multiple times. You can use multiple columns. But as I pointed out here, in statistics, we tend to keep everything based on column format and keep everything linked together. If you do have issues and things come out not as matrices, it is important to convert it back into a matrix so we can kind of keep things all together as one set of information. If you found this video helpful and you want to learn more about R, please like, share, and subscribe. And as always, until next time.